Welcome to ATA Team's 2023 Flight Readiness Review. In this video, we will present our unmanned aerial vehicle named Rafael. Comprising 24 undergraduate students from various engineering disciplines such as aeronautics, astronautics, electronics, mechanical, and artificial intelligence engineering, ATA Team consists of 4 distinct subteams. The mechanical subteam is responsible for the designing and manufacturing process of the aerial system. The avionics subteam works on the design of the electronic system architecture and the integration of the components to the system. Also works on autonomous operations via the ground control station. The software subteam designs the geolocation algorithms. Also, they both design and control the ground station interface. Lastly, the organization and sponsorship subteam handles the financial status of the team, communicates with the sponsors, and ensures the team is provided with the necessary resources. ATA Team's UA, Rafael, was first designed and manufactured in 2022. For the UAS Challenge 2023, a design and mission optimization process have been conducted in order to accomplish the competition task with increased performance. Rafael is a fixed-wing, fully autonomous unmanned aerial system with a wingspan of 2.97 meters and a dry operating mass of 7 kilograms. It is able to take off from and land within a distance of fewer than 10 meters and capable of up to 30 minutes of flight with a safe operational range of 5 kilometers. Rafael is configured as a mid-wing with a conventional tail. The wings and empennage of the previous year were downsized with the intention of reducing weight while simultaneously preserving its high aerodynamic efficiency. The fuselage was designed in such a way that it both satisfies a comfortable avionics layout and a minimized cross-sectional area in order to reduce parasitic drag, thus increase the aerodynamic efficiency. In order to sustain better maintenance and reduce installation time, the design was conducted regarding high modularity. The UA consists of 4 main parts: wingset, fuselage, an empennage, and the fuselage-empennage connection. The pin connections between the elements provide easy and faster assembly. Avionics systems and the flight controller have been tuned for the successful completion of Rafael's tasks. Rafael has fully autonomous flying capability from takeoff to landing. With antennas mounted on the fuselage, live telemetry transmission is ensured within the line of safe operational range. At the same time, the onboard computer calculates the precise timing of payload release by solving the necessary numerical equations. The takeoff performance was analyzed by a MATLAB code, including the required data of the takeoff parameters. Wing area and flap sizes are reconsidered for the mission requirements. The motor selection was reviewed by considering the previous year's entry, and it was decided to use the same motor. An estimation was conducted considering the drag force to assess how the deflection angle of the flap would impact the takeoff and landing distance. Based on the analysis, the takeoff distance was calculated as 4 meters under non-windy conditions. The analysis was then compared with the real takeoff scenarios, and various scenarios were implemented to ensure optimal performance in extreme weather conditions. The flight parameters of last year's entry were analyzed to achieve maximum flight efficiency. Various updates were conducted to reduce drag, and cruise performance was improved. During resizing, stability characteristics were not compromised while the aircraft was downsized. The performance analysis of the aircraft was examined both in the explained simulations and in test flights. Numerous scenarios were considered for various loaded and unloaded situations. During the test flights of the payload releasing system, by increasing the payload mass from 0.5 kilograms to 3 kilograms step by step, potential negative situations were prevented. Aerodynamic efficiency, motor, and propeller selection were taken into account for endurance performance. Several updates were conducted to face as low a drag force as possible. With the smaller wing and tail structure, it is aimed to increase aerodynamic efficiency. A split symmetry winglet was designed in order to reduce induced drag. To increase Rafael's range as long as possible, the thrust forces were compared using various propeller sizes. Rafael's maximum travel distance was determined to be 30 kilometers. Since the main objective of the UA is to carry and deliver a payload, the focus is on ensuring that the carriage and release system is safe and accurate. The release system is innovatively designed to avoid introducing any additional weight cost from the traditional releasing systems and to avoid drag after the payload is released. Release system melts the nylon lines passing through the nichrome lines of the air drop box to release the load. The nichrome wire is a high melting point material and have a proper resistivity. The onboard computer calculates the release point, taking into account variables such as speed, wind, height, heading, and the target point provided by the competition. After this stage, the release system is activated by the flight controller in response to commands from the onboard computer. A relay, along with a step-down voltage regulator, transmits the pre-calculated power to the nichrome wires. In order to maximize the obtainable score from the mission tasks, the mission configuration was optimized. A MATLAB code was created including the scoring parameters together with the loaded and unloaded battery discharge curves. Accordingly, the optimum mission configuration was determined. Based on the conducted test flights and ground tests, some components have been replaced and modifications have been made. In order to shorten the assembly time of the UA, instead of assembling the vertical and horizontal stabilizers one by one, the tail parts were fixed to a carbon fiber tube and the connection of the tail set with the empennage was changed with an interlock system consisting of two pins. The main battery was replaced with Tatu 16,000 mAh, which has more capacity, and the backup battery was replaced with Profuse 1800 mAh. For more precise current measurement to calculate the waypoint course, the Pixar power module was replaced with Holybro PM02V3. Furthermore, an additional safety switch was installed on the second power line to enhance the system's safety measures. To ensure the reliability of the electronic system during mission, a comprehensive ground simulation was conducted, including system endurance and thrust testing. Additionally, temperature measurements were taken at critical points of the system. This was done to confirm that the electronic system would not encounter any issues during the actual flight operations. A range test was conducted to ensure the aircraft's ability to perform its full mission, and satisfactory results were obtained that meet the competition requirements. To assess the aircraft's tolerance to unexpected weather conditions, a waterproofness test was carried out. Additionally, simulated environments and ground tests were conducted to assess the performance of the flight termination system and determine the UA attitude. Lastly, to ensure the reliability of the ground control station, it was decided to use Mission Planner. A pre-flight checklist is prepared, consisting of two main sections as mechanical controls and avionic controls. The checklist ensures that the UA is assembled correctly and all subsystems are working properly, eliminating any negligence which may threaten the flight safety. Lastly, a post-flight checklist is also prepared in order to review the condition of the UA and each subsystem following the flights. The team's safety pilot Yılmaz Kömürcü is an experienced UA pilot holding flying licenses from both British and Turkish civil aviation authorities. All test flights of Rafael have been performed by Yılmaz Kömürcü since the beginning of the test period of the UA. Rafael is ready for its mission, and we are more than excited to see it in the Buckminster sky.